This is a uniform motion problem, and uniform motion problems are also called DRT problems. And the reason they're called DRT is because they deal with the distance, and the distance is equal to your rate times your time. So we usually abbreviate this D is equal to RT. To solve any of your DRT or uniform motion problems, the best way to do this is to make yourself a chart. So you're going to have a column that says is your distance, you want a column that is your rate, and you want a column that is your time. So now we're going to be reading the story problem here, and we have Josie traveled to the town hall and back. So this is telling us where we're traveling. So to the town hall and back from the town hall. Then we start filling in these columns. The trip there took 5 hours. So right here, this is telling me which column I need to put this in. If we're talking about hours, we're talking about a time. And if we're talking about a time, then we put it under our T column. So the trip there, so that would be going to the hall, is going to be 5 hours. And the trip back took 4 hours. So that would be back from the hall. That's going to be 4 hours. He averaged 35 kilometers per hour. This is a rate. Whenever you have some distance per unit time, that is a rate. So remember, rate is a distance per unit time. So my distance here is kilometers, my time is hours. And that is on the return trip. So coming back, we average 35 kilometers per hour. Then we need to find the average speed of the trip there. So we're looking for R. So I'm just going to put an R there. Once you have two columns filled in, which is what we have right here, we have our R column filled in and our T column filled in, we go ahead and use the formula D equals RT to fill in that last column. So to find my distance, I need to take my rate times my time. So I'm going to do that for the distance to the town hall. It's going to be my rate times my time, which gives me 5R. And then back from the town hall, my rate times my time, which is 4 times 35. Then I use this column, the last column that I filled in, to come up with my equation. And what do I know about the distance to be able to write my equation? Well, I know that the distance to the town hall and the distance back from the town hall had better be equal if we went the same direction. So that means that my distance there, 5R, has to equal my distance back, 4 times 35. Go ahead and multiply 4 times 35. When you do that, you should come up with 140. Then you need to solve for R, so we're going to divide both sides by 5. The 5's over here cancel out, and we are left over with R equals 28 kilometers per hour. And that is the average speed of the trip there, 28 kilometers per hour. The second problem we're going to look at is a fishing boat that left Hawaii traveling west 0.5 hours before a cruise ship. Okay, so again, we're talking about traveling. We have hours. Later on in this problem, the cruise ship traveled in the opposite direction, going 12.5 kilometers per hour, so we have a rate faster than the fishing boat. Then we have a time over here, and then it says after the ships are 322 kilometers apart. So we're definitely talking about a DRT problem. And we have a fishing boat and we have a cruise ship. So that's what I'm going to put over here. We're going to have our fishing boat and our cruise ship. We're going to have the distance, the rate, and the time. So the fishing boat left Hawaii traveling west. And it might be helpful for you to draw yourself a little diagram. Sometimes it helps me to do that. So if I want to, the fishing boat is traveling west. Okay, so here we are, and our little fishing boat's going to the west. And it starts a half an hour before a cruise ship. So that means that the time of the fishing boat's going to be half an hour more, or plus 0.5 hours compared to the cruise ship. The cruise ship traveled in the opposite direction, going 12.5 kilometers per hour faster than the fishing boat. And then it did that for 11 hours. So the cruise ship did it for 11 hours, and the fishing boat did it for 11 plus half an hour, so 11 and a half hours. Okay, next we have the cruise ship traveled in the opposite direction, so it's going to the east, and it was going 12 and a half kilometers per hour faster than the fishing boat. So that means that I have to be faster than the fishing boat, so I'm going to be adding 12.5 kilometers per hour than the fishing boat. Well, what's the rate of the fishing boat? Well, it doesn't tell me anywhere in the problem. So I'm just going to say that that's R. So that means the cruise ship is going to be R plus 12.5. Okay, so then I've got my two columns filled in. To fill in the third column, I'm going to again use my formula, D is equal to RT. So I'm going to take my rate times my time. And remember, my time here is going to be equal to 11.5 hours altogether. So when I take my rate times my time, I end up with 11.5 R. And then I need to do this also for the cruise ship, and I'm going to take my rate times 11. And remember that my rate is an expression, so I'm going to put the 11 on the outside, and I'm going to put R plus 12.5 on the inside. So this expression is my rate for the cruise ship. Then I use this information, this column, to use my distance, to find my distance, and then that's where we're going to use the 322 kilometers. If they start at the same point and go in opposite directions, I want to know when will they be, what is the fishing boat speed when they are 32 kilometers apart. So I'm going to go ahead and set up my equation now, and I'm going to use my D column. So I'm going to have 11.5 R, and that's the distance that the fishing boat is going, plus 11 times R plus 12.5. That represents the distance that the cruise ship is going. And those two distances added together had better equal 322 miles. And that's the hardest part, is just setting it up here. So this is the distance that the fishing boat went. This is the distance that the cruise ship went. Together, they're going to end up being 322 miles apart from each other. So go ahead and use your distributive property. So you have 11.5 R plus 11 R plus 137.5. 11 times 12.5 is 137.5 equals 322. Combine like terms. So you can combine 11.5 R and 11 R, and you end up with 22.5 R plus 137.5 equals 322. Then you want to get the term that has your R in it by itself, the 22.5 R. You want to get that by itself. To do that, you're going to need to subtract 137.5 from both sides of your equation. You end up with 22.5 R equals 184.5. Then you want to get the R by itself, so you're going to divide both sides by 22.5. These cancel out. You're left over with R is equal to 8.2 kilometers per hour.